are renowned for the contribution to philosophy, art, literature, and science. So, their philosophical inquiries, spearheaded by thinkers like Socrates, Plato, and Aristotle, so established the foundation of Western philosophy, shaping ethical and political thought for centuries. So, simultaneously, their artistic achievement is exemplified by iconic structures like the Parthenon and sculptures such as like Venus de Milo. So, set aesthetic standard that continue to inspire. So, the literary masterpiece of Homer's is Kaan. So, Sophocles' Euripides enrich storytelling and dramatic art, providing enduring narrative and exploring profound human themes. So, furthermore, the scientific achievement of the ancient Greeks were remarkable. Archimedes' contribution of mathematics and physics, Pythagoras'
Kindly read the PowerPoint below since I will just give a quick explanation. So, letter A, or I will just explain the alchemist. This statement emphasizes how alchemists, despite their mystical focus, contribute significantly to modern chemistry by developing experimental techniques. Identifying elements and creating laboratory tools, their work ultimately influenced atomic theory and evolution of chemistry as a science. So, or letter B, this statement highlights specific contributions of alchemists, such as inventing techniques like distillation and creating lab equipment. Is still in use today. It also notes that they were the first to isolate certain metals, laying the foundation for modern elements discovery.
And Jessica J. Yuan Solarisi. This was something the alchemists were not sure about himself. As they continued working, they started to realize that there was no way to return substances such as mercury, sulfur, etc. to anything simpler, and although this does not necessarily mean that they are composed of atoms, it started to introduce the idea that chemical substances are through the combination of these elements. So letter D. The concept of the atom that was Western scientists accepted in broad outline from the 16,000 until about 19,000 originated with Greek philosophers in the 5th century. Their speculation about the hard, indivisible fundamental particles of nature was replaced slowly by a scientific theory supported by experiment and mathematical deduction.
According to J.J. Thomson, the mass spectrometer it is an analytical tool useful for measuring the mass-to-charge ratio of one or more molecules present in a sample. So basically, measurements can often be used to calculate the exact molecule weight of the sample components as well. Then isotopes are different forms of the same element, meaning they have the same number of protons and therefore the same atomic number, but differ in the number of neutrons, leading to various in their atomic mass and physically properties. J.J. Thomson used cathode tube to discover the presence of electrons. Cathode tube was most commonly known on old television sets.
Ernest Rutherford work fundamentally changed our understanding of the atoms. He's the most important discovery of the atomic nucleus, then positively changed core of the atoms. Rutherford achieved this breakthrough his famous gold foil experiment. So, in this experiment, he spied alpha particles at hand sheet of gold foil the surprising result. So, show the most of the particle pass straight to indicating that atoms are mostly empty space. However, a small number of particles we deflected at large angles and some have bounced back toward the source.
Have here the nuclear model of Ernest Rutherford. Well, this model replaced J.J. Thomson's plum pudding model and introduced the concept of a dense positively charged nucleus at the center of the atom. We have the key features of the nuclear model. First is the tiny dense nucleus. The atom's mass is concentrated in a small central nucleus containing positively charged protons. Then the second one is the mostly empty space. Electrons more orbit the nucleus at a distance, meaning most of the atom is empty space. The third one, it is the electron motion. Electrons move around the nucleus but are not embedded in a uniform pudding as Thomson had suggested. And the fourth one, or maybe the last one, is the explained scattering of particles.
Henry Moseley. It is said there that his contributions to atomic theory is his work established the concept theory of atomic number. So basically, in the concept theory of atomic number, Moseley discovered that the number of positive charges in the nucleus of an atom, which is its atomic number, is a fundamental property of the element and is responsible for the element's characteristics. He also helped rebuild the structure of the atom. To add up, year 1913 was the year Moseley contributed to atomic theory. In chemistry, his contribution is his work helped predict the existence of undiscovered and new elements and also their properties, as his law allowed scientists to identify the gaps in the periodic table. Moseley's experiment that led to his discoveries is he bombarded various metal targets with electrons, causing them to emit X-rays. He then analyzed the wavelengths of this X-ray using X-ray spectrometers, because Moseley sees this tool as a powerful tool for analyzing the composition and structure of the matter. That's why he discovered that each element has a unique X-ray spectrum, a sort of fingerprint. Also, he found a simple relationship between element spectrum and its atomic number. Moseley's research provided crucial insights in the structure of the atom, particularly in the nucleus, and the arrangement of electrons within it. That's why his work influenced our current understanding of atomic structure, because as he collects the X-ray spectrum of a variety of elements, he found frequency of X-ray radiation, which has a precise mathematical relationship, and that now is called Moseley's law. In Moseley's law, he has measurable physical quantity and he created its formula, where it shows the relation between the frequency of characteristics, X-rays, and the atomic number C. To add up, until Moseley's work, atomic number was merely an element's place in the periodic table, and is not known to be associated with any measurable physical quantity. Also, this shows how elements were arranged thereafter, not based on the atomic weight but based on the atomic number.
So, Niels Bohr made significant contribution to atomic theory by introducing the concept of quantized energy level for electrons. In 1913, he refined Rutherford's model by proposing that electrons orbit the nucleus in fixed paths or energy level, preventing them from spiraling into the nucleus. His model explained why atoms emit specific color of light which could not explained by earlier model. He introduced the idea of quantum jumps of light, which could not be explained by earlier models. He introduced the idea of quantum jump, where electrons observe energy to move to a higher level, release a light when returning a lower level. This breakthrough laid the foundation for modern quantum mechanics and revolutionized the understanding of atomic structure.
So as you can see here in the slide, we have the illustration of Niels Bohr's atomic model. So first, Niels Bohr's atomic model describes how electrons are arranged in atoms. He proposed that electrons orbit the nucleus in fixed energy levels or shells, much like planets orbiting the sun. However, unlike planets, electrons can only exist in specific orbits and cannot be in between. Electrons revolve around the nucleus in circular paths called energy levels or shells. So in the shells there, energy increases as the distance of the orbit from the nucleus increases. So each energy level is assigned a number, like n is equal to 1, 2, 3, where n is equal to 1 as the closest to the nucleus and has the lowest energy. Further the energy level is from the nucleus, the higher the energy of the electrons is in that level.